So I renamed this method to traverse depth first rec, as in recursive. I didn't want to delete the code here and change our implementation because I wanted you to have all the code we have written in this project. But technically, you should never name your methods like this. This is a bad practice because the name of a method should not talk about how it's implemented. That's implementation detail. If tomorrow we change the implementation detail, we don't want to rename our methods. That will affect the consumers of our methods, okay? So we need a new method, public void traverse depth first. Just like before, we give it a root node. Now here we want to validate the root node first. So let's call nodes.get, get this root node, and see if it's null, then we're just going to return. Otherwise, we're going to push it onto our stack. So first, let's create a stack of nodes. We're going to import the stack class that is declared in the java.util package. So a stack of nodes, we call it stack, and initialize it like this. Now we call stack.push and give it this root node. Now, while our stack is not empty, we're going to pop one item. So stack.pop, we store the result over here. Now we want to visit this node as well as all its unvisited neighbors. So here we need a set to keep track of the nodes we have visited so far, just like before. So I'm going to create that over here, a set of nodes. We call it visited and set it to a new hash set. So every time we get a node, we want to make sure that we haven't visited this before, because in a graph, it is possible that we get to the same node via multiple paths. So if our visited set contains this current node, then we're going to continue, which means we're going to jump to the beginning of a while loop and get another node from our stack. Okay. Otherwise, we're going to print the current node on the terminal and add it to the list of visited nodes. So visited.add current. Now we're going to look at all its unvisited neighbors. So for each neighbor in adjacency list that get current. This is exactly the same logic that we had in our private recursive method. It's exactly the same. Now, if we haven't visited the neighbor, we're going to push it onto our stack. So stack.push the neighbor. That's all you had to do. So let's take a look. So initially we validate our node, then we create the set of visited nodes. We also create a stack and push the root node here. Now, while the stack is not empty, we pop one item. We want to make sure that we haven't visited this node before. Then we're going to visit it. And finally, we're going to look at all of its unvisited neighbors. Let's test our algorithm. So back to the main class, I'm going to call the traverse depth first method without recursion and give it A. So we get A, C, B, D. What if we pass the C here? We only see the C. What about an invalid node? Everything working properly? Beautiful. Next, we're going to look at the breadth first traversal algorithm.